how to balance a chemical equation. Here we can see nitrogen combining with hydrogen to form ammonia. On the left side are the reactants of the formula. On the right side is the products. Our reactants combine to form our products. However, this equation is not balanced. We can see that we do not have the same amount of nitrogen on both sides and the same amount of hydrogen on both sides. On our left side, the reactant side, we can see that we have 2 nitrogen atoms. We know that it is 2 because 1 is always invisible, times 2 equals 2. So we have 2 nitrogens. We can also look at our hydrogens. Our hydrogens also have 2. This 2 times the invisible 1 gives us 2 hydrogen atoms. So by looking at our left side, we can tell that our equation has 2 nitrogen atoms and 2 hydrogen atoms. Now let's go to the right side, the product side. We can tell that we have 1 nitrogen atom because there's an invisible 1 here and an invisible 1 here. 1 times 1 is 1. Now we can look at our hydrogen. Our hydrogen has 3. 3 times the invisible 1, that would be right here. Here, we can see that our equation is unbalanced. We know this because our left side, our reactants, has 2 nitrogens. However, our products only have 1. Our reactants also have 2 hydrogens, and our products also only have 3. The signs between the reactants and the products are the not equal sign. These show that 2N does not equal 1N. 2H does not equal 3H. In order to balance this equation, we need to add some more ammonia, the NH3. We're going to double the amount of ammonia in the equation. Now that we have doubled the amount of ammonia, we will have 2 nitrogen atoms, because the big number in front, 2, multiplies the invisible 1 on the nitrogen. We will also have 6 hydrogen atoms, because 2 times 3 is 6. Now, our nitrogens are fixed. We have 2 nitrogens on both sides. However, now we need to fix our hydrogens. On the left side, we have 2, and on the right side, we have 6. So we know that we have 6 hydrogens because this big number up here multiplies a small number here. 3 times 2 is 6. Now, all we have to do is fix the hydrogens on the left side. We know that we have 2. So now all we have to do is multiply this by 3. If we multiply by 3, we can see that 3 times 2 gives us 6. So there we go. We have a balanced chemical equation. Both sides have 2 nitrogen atoms, and both sides have 6 hydrogen atoms. Here are some rules when you're balancing equations. You are only ever allowed to change the big numbers. I am allowed to put a 3 in front of the hydrogen, but I am not allowed to put a 3 under the hydrogen. You are never able to change the small number. You have to leave it alone. Only the big number can be changed. You cannot add or subtract any elements or molecules. You have to stick with what you are given. Here are a few more worked examples. One tip is to always balance the O's first. Once we balance the O's, everything else falls into place. Now we have a perfectly balanced equation. On our left side, we have 2 times 2, 4 iron atoms. On our right side, we have 4 times 1, 4 iron atoms. On our left side, we have 2 times 3, 6 oxygen atoms. On our right side, we have 3 times 2, 6 oxygen atoms. On our left side, we have 3 times 1 is 3 carbon atoms. Our right side, 3 times 1 carbon atoms. Once again, 3 carbon atoms, 3 carbon atoms, 6 oxygen atoms, 6 oxygen atoms, 4 iron, and 4 iron. So now we have a balanced equation. Let's try a more complicated example. If you're watching this, maybe you should pause it and see if you can work it out by yourself first. Then hit play and see how I do it. Well, looks like our equation was already balanced for us. But we were able to double check to ensure that we have the correct equation.